All right, guys. So last time we talked about empirical formulas. This time we are going to talk about taking it a step farther and using empirical formulas to start generating molecular formulas. Okay, so molecular formulas indicate the actual number of atoms in each type of molecule or the actual mole ratio in each mole of a molecule. It's possible for molecular and empirical formulas to be identical if they have the same simplest whole number ratio. That's the case with, for example, water. I can't get any more simple than H2O. There's 2 to 1. There's no common multiple or factor in there. To find the molecular formula, the process is essentially similar to finding the empirical formula, but the molecular mass is given, so we have a last step that we need to do. Okay, so here we go. Example 11. Succinic acid is a substance produced by lichen. I don't know if you've ever been down to Red Rock country, but if you've ever seen the black, sometimes it's kind of a light, smoky sage green, but it's a little plant, for lack of a better word, that grows on the rock where the water seeps through the rock. So you get these little simple plant. It's actually a plant with a fungus living symbiotically together. Chemical analysis indicates that it's composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. And we have a molar mass of 118.1 grams per mole. Determine the empirical and the molecular formulas of succinic acid. So the very first thing we're going to do is, just like empirical formulas, we're going to pretend that we have 100 grams of this stuff. So that means I'm going to have 40.68 grams of carbon. The first thing I need to do is get all of these into moles. So I need to find how many grams of carbon there are in 1 mole of carbon. So I'm going to look at my periodic table. So if I look at my periodic table, I've got 12.011. That's going to simplify to the 100th, 12.01. So 12.01 grams. So I'm going to take 40.68 and divide it by 12.01. So we are going to have 3.387 moles of carbon. Okay, now I'm going to do the same thing with hydrogen. So I have 5.08 grams of hydrogen. And in 1 mole of hydrogen, I have 1.01 grams of hydrogen. Now I just have that memorized. I should probably show you where I pulled that off the periodic table. So 1.008 will simplify to 1.01. Okay, so 5.08 divided by 1.01 gives me 5.029 moles of hydrogen. Okay, and then I have 54.24 grams of oxygen. And we've dealt with oxygen a lot. In 1 mole of oxygen, I have 15.999. That will simplify to 16.0. Oh, wow. I have, 54.24 grams of oxygen. That really took a lot of my stuff away. 1 mole of oxygen, 16.00 grams. So 54.24 divided by 16 gives me 3.39 moles of oxygen. Now, do you guys remember the next part? We always had to find the least number of moles. So which one's the smallest? Isn't carbon the smallest? So we're going to use carbon as our divisor here. So I'm going to divide everything by 3.387. That's going to give me 1. Divide this by 3.387. That gives me 1.5. And if I divide this by 3.387, that also gives me 1. Now, this is not a whole number right here. So that means I have to multiply by something that will give me a whole number. And that means I have to multiply everything by that same thing. So 1.5 times 2. Doesn't 1.5 times 2 give me 3? So I'm going to multiply everything by 2. So 1 times 2 is 2. 1 times 2 is 2 here as well. So that means my simplest whole number is I've got 2 carbons, I've got 3 hydrogens, and I've got 2 oxygens. Okay? So when I write this formula, I have C2H3O2. Now that is my empirical formula. That is not my molecular formula. The next thing I need to do, here's our next step. That makes it a little bit different. I need to find the mass, the molar mass of this empirical formula. So 2 carbons plus 3 hydrogens. I'm going to give you guys a second to come up with that molar mass. So 2 times 12.01 for the carbons, plus 3 times 1.01 for the hydrogens, plus 2 times 16.00 for the oxygens. This gives me an empirical mass of 59.05 grams per mole. Now, the next thing we've got to do is we've got to see if it matches our molecular mass. We have a molar mass of 118. Does that match? No, it does not. So the next step is we have to figure out how many empirical units are in 1 mole. That's the next thing we've got to figure out. So I'm going to take my molar mass and I'm going to divide it by my empirical mass. And I'm going to see the whole number ratio there. So 118.1 divided by 59.05 will give me 2. That's how many empirical units are in a molecular unit. So that means I've got to take everything in my empirical formula and multiply it by 2. So 2 carbons times 2 would give me 4 carbons. 3 hydrogens times 2 would give me 6 hydrogens. And 2 oxygens times 2 would give me 4 oxygens. So this would be my molecular formula of succinic acid. Okay, so C4H6O4. So beyond the empirical formula, I have to find the empirical formula weight. Then I have to figure out how many empirical formula units are in a molecule to find the molecular formula. Okay, let's do another example here. So the molecular mass of a compound is found experimentally to be 91.1 grams. Analysis of the compound shows that a particular sample, there is 0.608 grams of nitrogen and 1.338 grams of oxygen. What are the empirical and the molecular formulas for this compound? Notice I don't have things in mass percent. So I'm going to actually use the grams that are given to me and get them into moles. So I don't even have to pretend that I've got 100 grams of this stuff. I'm going to just use the grams that I have. So 0.608 grams of nitrogen In 1 mole of nitrogen, how many grams of nitrogen do I have? Let's look at our molecular mass really quick. So nitrogen, 14.01. So I've got 14.01 grams. So I'm going to take 0.608 divided by 14.01. This gives me, okay, let's let this think for a little bit. This gives me 0.04339 moles of nitrogen. I'm going to do the same thing for my oxygen. So I have 1.388 grams of oxygen. In 1 mole of oxygen, I have, do you guys remember? We can cheat right here. 16 grams of oxygen. So 1.388 divided by 16 gives us 0.08675 moles of oxygen. Do you guys remember what the next step is? Yeah, that's right. So we need to find the smaller of the two amount of moles and use that as a divisor. So hopefully you realize that that was nitrogen. So I'm going to divide by 0.04339. And of course, if I divide by anything by itself, I get a ratio of 1. So let's divide that 0.08 by 0.04339. And I get 1.999. That's pretty dang close to 2. So that means I have 1 nitrogen for every 2 oxygens. Now that's my empirical formula. Okay? Do you guys remember what the next step is? I need to find the empirical formula mass. So if I look at 1 nitrogen, so 14.01 plus 2 times 16 for the 2 oxygens, that gives me a mass of 46.01 grams per mole for the empirical formula. Does it match what we have for the molar formula? Okay, so when we look at the molecular formula, mass is 91. It doesn't match. So what we need to do is find out how many empirical units there are in a molecule unit. So I'm going to take 91.1 divided by 46.1, and I'm going to see what that whole number ratio is. So 91.1 divided by 46.1, that gives me 1.976, which is super close to 2 for a whole number. So that means I need to multiply my empirical formula by 2. So 2 times 1 for my nitrogen is 2 nitrogens, and 2 times 2 for my oxygen gives me 4 oxygens. So this compound is going to be dinitrogen tetraoxide or tetroxide. Now remember, we can use that A or not. Okay? So, compound example 13. A compound containing hydrogen, carbon, and oxygen has a molar mass of 180 grams per mole. It's 41% carbon, 4.6% hydrogen, and the rest is oxygen. So the first thing we've got to do is figure out the percentage of oxygen. So 100 minus 41 and also minus 4.6 gives me 54.4% oxygen. So that's what we're going to use for our oxygen. Okay, so let's start with our carbon. So I'm going to pretend like I've got 100 grams. So 41 grams of carbon. In 1 mole of carbon, do you guys remember the mass of carbon? 12.01. So I've got 12.01 grams of carbon in 1 mole. So 41 divided by 12.01 gives me 3.41. 3.41 moles of carbon. Now I do the same for hydrogen. So I have 4.6 grams of hydrogen. In 1 mole of hydrogen, I have, let's see, what's the molar mass of hydrogen? Do you guys remember? 1.01. So 1.01 grams of hydrogen. So 4.6 divided by 1.01. This gives me 4.55 moles of hydrogen. And I do the same thing with oxygen. So 54.4 grams of oxygen. In 1 mole of oxygen, our molar mass is, do you guys remember? 16, right? So 16.00 grams of oxygen. So 54.4 divided by 16 gives me 3.4 moles of oxygen. 3.40. Okay, so which one is, what's the next step? The next step is to find which one is the smallest. So we're going to use oxygen, 3.40, as our divider.